Okay, so this is 10-7, areas of circles and sectors. So this section obviously has more relevance to the unit as far as finding area, because that is our ultimate learning goal for the entire unit, is being able to apply area formulas in different complex situations. We had to stop for a second and do circumference so that you can have the background knowledge for this section. But now that you've struggled through the proportional formula for length of an arc, this section is going to be much easier because now you kind of have the hang of it. And it's the same idea as length of an arc when we're finding area of an arc. First, let's start with just the basic area of a circle formula. Area of a circle. Example. If I give you that and tell you that's 13, area equals pi r squared. In this picture, you're not given r, you're given the diameter. So how do you find r? Okay. Well, the radius is always going to be half of the diameter. Radius is equal to d divided by 2. So that's 13 divided by 2, which is 6.5. Now you just plug in. Area equals pi 6.55 squared. Type it in the calculator. You get 132.7. Okay. Not too hard. Just remember with these formulas, I'm giving you a pretty basic example, but the question could also give you the area and ask for the radius, right? So be prepared to solve these problems backwards. They might give you area and ask for circumference, in which case you would need to start with your area, find your radius, and then use that radius to find your circumference. So be prepared to do multi-step complex questions with this knowledge. All right, let's talk about area of a sector. Okay, a sector is just the part of the circle that's enclosed by the arc and the central angle. So it kind of looks like a slice of pizza. Okay. Which you can imagine can be very useful, because if you know the area of a slice of pizza, you can figure out how many calories or whatever is in it. Okay? So again, proportional. Okay? Your formula is going to be very similar. One ratio is going to be based off the angle, and the other ratio is going to be based off of, instead of length, this time it's going to be area. Okay, so you're looking at that central angle for one ratio, and then you're going to do area for the other ratio and then solve it. Okay, if I tell you that's 4, and this angle is 50, then I have 50, because that's the angle of the sector, over the total angle of the circle. Remember, it's the part of the arc, and then over the total. And that's going to equal, you're trying to find area, so that's your x. Okay. And you're going to put it over the total area of the circle. Remember, the bottom part of the ratio is always the total circle. Our r is 4, so pi 4 squared. So we were able to plug in for everything except for the area of the sector, which means we should be able to cross multiply and solve. Okay. Alright, so we just multiply by pi 4 squared, multiply by pi 4 squared. That cancels, and if you put all that in the calculator, you should get 6.98. So again, same exact proportion as yesterday. The only difference is that this is area instead of circumference. And again, you might be asked to solve more complex questions. They might give you the area of the sector, and they might ask for the angle. So you might have to do this backwards. Just ask yourself, what do I know and what do I don't know, and plug into what you can. All right. Area of a segment. Now, this segment isn't the same meaning as a regular segment, like part of a line. I don't know why they didn't pick a different word. I wasn't alive. when they decided to name this, but it's not the same thing you can think of as a segment. A segment is when I have a central angle, okay, which gives me a sector, and if I connect these two endpoints with a straight line, then this part right here is called a segment. Okay, so basically it's formed by a chord. This is a chord, and it's the part that's cut off from the chord. Okay. Alright. You're going to want to learn this, okay, because I can't do it right now because of all my tournaments, but before we leave for spring break, I am going to do an activity that I've done in years past where I bake a large cookie cake. And I cut the cookie cake into sections. Some of them will be arcs, some of them will be triangles, some of them will be segments. And if you find the area of the piece, your group gets to have that piece and split it and eat it. So if you want some cookie cake, I would suggest you paying attention and trying real hard in this section. Alright, so how do you find the area of this piece? It's not exactly an easy shape, okay? What we're going to do is we are going to do the area of the sector. Remember, the sector is this whole thing, right? It's the whole pizza slice. Okay? And we are going to subtract the area of the triangle. Okay? So this is an isosceles triangle, by the way. So let me write isosceles triangle. So we have to find the area of both of those pieces and subtract them to get the green piece. Okay. Alright, area of a sector. Just did this on the last example. Okay. If this is 6 and this is 35, how do you find the area of that sector? We make our ratio. 35 over 360. Remember, that's the angle over the total. And then we're going to do area over the total area. The R is 6. That's pi 6 squared. Okay. Multiply on both sides. Pi 6 squared. That cancels. And I am left with 10.996. Now I need to find the area of the triangle. Okay. There are two different ways to do this. I think the easiest way is to use the newest triangle formula that you just learned, but let me show you both. Alright. We're going to call this the old school method. The old school method is you have an isosceles triangle. That's 6 and 6. You draw your heights. Right? Okay. You know that this total angle is 35, so you do half of that. And I'm going to need my calculator because I didn't do it this way last year. And so that's going to make this angle 17.5. Okay, and we need the height of the triangle, and we need this bottom part so we can double it and get the base. Okay, so we're going to do some trig. We have our hypotenuse, we need our adjacent and our opposite, so I can do sine of 17.5 equals opposite, which is y, over hypotenuse, which is 6, multiplied by 6. So y equals 9 degrees, so 17.5 sine times 6. That gives me 1.80. And that's y, which means my base would be that times 2. Is 3.608. We also need the height of the triangle, so now we got to do cosine. 17.5 equals adjacent, which is x, over hypotenuse, which is 6, times by 6. X equals 18.5 cosine times 6, 5.722. Then we have area equals 1/2 base times height, which is 1/2 times 3.608 times 5.722. Let me color code this for you, those of you having trouble following along. Okay, so for our y, we did all of that. Then, because we needed the entire base, we had to double it. Then, for our height, we did this, and then we plugged in to get the area. Okay, let me multiply this out for you. 3.608 times 5.722 times 0.5, I get 10.322. So that's the old school method. Kind of complicated, okay? But it's easy to remember because you've used this formula longer. Here's the new school. You're going to like this one better, but you will have to remember the formula. Remember, we just learned about this formula. Alright? You can use this formula anytime you have an angle and the two sides next to it. Remember, this is an isosceles triangle, so that one is also 6. So you have two sides plus the included angle, which means you can use this formula. All you got to do is plug in 6, 6, sine of 35. Much, much, much easier. I have had kids not like this. I don't know why, but if you want to use this method, you're more than welcome to. But really, this one is going to be much easier. So sine of 35 times 6 times 6 times 0.5. And you'll notice I get pretty close to the same answer minus some rounding errors. Okay? Alright, so again, so this was for the sector, and either one of these methods is for the triangle. And what was our ultimate goal? Was to subtract them, right? We have to take the area of the sector, and we're going to take away the triangle, and that should leave just the green area. Okay? So we have, the area of the sector was orange, so that's 10.966. We're going to subtract the triangle, which is pink, which is 10.324. Okay. And that equals 0.672. Okay, so we had a sector, which again was the orange part of the picture, minus the triangle. If you were to take that slice of pizza and you were to cut across the end point, and it's basically like the crust that is left over. So that's why this number is so small, because you're basically taking all of the cheesy part of the pizza off, and all you're left with is that crust. Okay? And that's how you find the area of the sector. I mean, a segment.